Hello, my name is Hassan. In this video I will show you how to find the derivative of e to x. Let's start by writing f of x is equal to e to x, and the definition of the derivative, which is d by dx f of x is equal to limit of f of x plus h minus f of x divided by h as h goes to 0. Then we insert f of x is equal to e to x to find limit of e to x plus h minus e to x divided by h as h goes to 0. Now, how can we find this limit using the definition of the number e? Now, at this point we need to recall the definition of the number e. It's defined as the limit of 1 plus 1 over n to the power n as n goes to infinity. At this point, one way to proceed is to derive a useful identity as follows. Let us start with a blank page and write down 1 plus 1 over n to the power nx plus 1 is equal to 1 plus 1 over n to the power n times, in parentheses, x plus 1 over n. We did nothing but factorize the exponent. Soon it will be clear why we start from such identity, but for now it looks promising since the expression looks like the definition of e except for the limit as n goes to infinity. So let's continue. On the left hand side we can factorize to two terms with the summed exponents, which are 1 and nx. On the right hand side we write the term to the power n times x plus 1 over n as the same term to the power n to the power x plus 1 over n. Then on the left hand side we use distribution law to find 1 times 1 plus 1 over n to the power nx plus 1 over n times 1 plus 1 over n to the power nx. We keep the right hand side the same. In the next step, we solve for the term shown in red to find 1 plus 1 over n to the power nx is equal to 1 plus 1 over n to the power x plus 1 over n minus 1 plus 1 over n to the power nx, all divided by 1 over n. Okay, now if we take the limit of both sides of the equation as n goes to infinity and recall the fact that e is equal to the limit of 1 plus 1 over n to the power nx as n goes to infinity, we get e to the power x on the left hand side and e to the power x plus 1 over n minus e to the power x divided by the reciprocal of n on the right hand side. So we write it down below. Then at this point, if we substitute 1 over n with h, then as n goes to infinity, h goes to 0, which gives us e to the x is equal to the limit of e to the x plus h minus e to x divided by h as h goes to 0. This last expression is nothing but the derivative of our function d by dx f of x, which we had shown earlier. So this completes our solution. Thus, the derivative of e to x is again e to x. Thank you very much for watching this video.